So you should have this handout in front of you. There are 2 copies in each package. You only need one of them. So factoring difference of squares. So if you recognize that this is a perfect square and this is a perfect square, then we can factor them using a special pattern. In order to do this, the degree must be even. So a degree of 2, 4, 6, 8, 10, right? The degree must be even. The number of terms has to be 2 in order to use this pattern, which would be a binomial, right? First term, second term. And then A and C must be perfect squares. What that means is that A couldn't be 7, C couldn't be 5, right? It'd have to be something like 9, 16, or 25, or 36, perfect squares. So I'm going to give you a chance to pause the video and write down all of the notes. One thing I want to make sure that you notice is that in order to use this pattern, it's got to be the difference of squares. Okay, what that means is that this must be a subtraction symbol. Okay, cannot be a plus sign, can't be addition, it doesn't work. Okay. If it was an addition symbol, we would just say that it's not factorable, and we'd leave the answer as is. Alright, so first example, we're going to factor 81x squared minus 36. So let's say you didn't recognize this pattern, and you wanted to use the AC method. So that's ax squared plus bx plus c. Now there's no bx, right? There's no term in the middle. So this is what you would do. Again, pretend you don't know the pattern. Okay. We would change this from 81x squared minus 36 to 81x squared plus 0x minus 36. So now we have an A, a B, and a C. And then I would slide, right, because I don't recognize a pattern here. So I slide. This becomes x squared plus 0x minus 81 times 36, 2,916. And so in my X puzzle, I'm trying to find numbers that add up to 0 and multiply to negative 2,916. And holy smokes, that's going to take a while, right? So that's where this pattern comes into play, because we don't want to do that. We have 81x squared minus 36. Let's see if we can use this pattern. First, is there a subtraction symbol? Yes. Okay, that's the first step. So where is the difference? Is 81 and 36 perfect square? So 81, right, is the perfect square of 9. 36, perfect square of 6. So that works. So we can use this pattern. And what I do is I set up my parentheses. Okay. And now let's take a look at step 1. Step 1 says take the square root of the first term. So I have 81x squared. And if I take the square root of that, I get 9x. That number is going to go first in each of the parentheses. So 9x, 9x. Okay. That one goes here and here. Step 2 says take the square root of the second term. Well, that's 36. So that's the square root of 36, which is 6. And that number goes here and here. And the last one says make one addition and one subtraction. So that's addition and subtraction. So my final answer is, just to make it bigger, 9x plus 6 times 9x minus 6. And if I were to FOIL to check that, 9x times 9x is 81x squared. Outside, 9x times negative 6 is negative 54x. inside 6 times 9 is 6 times 9x is positive 54x. These cancel. 6 times negative 6 is negative 36. And that's why this pattern works out. Okay, that's why there's no number in the middle for these ones, because it always cancels out. So that's the pattern called difference of squares. Right? It would be much easier using that method than that method. Okay? That's one of the special cases. Here's another example of factoring difference of squares. So the degree is even because it's 4, right? And I know I have two perfect squares because technically this is a 1, right? Square root of 1 is 1, square root of 16 is 4. So I can factor this one using that pattern. Typically we don't have a 1 there, so I'm going to erase it. Okay. And then let's go through that pattern. So we're going to set up our parentheses. First step is to take the square root of the first term. First term is b to the 4th, so the square root of b to the 4th is simply b squared. And that goes here and here. Now I take the square root of the second term, which is the square root of 16, which is 4. And that goes here and here. And then one is separated by addition, one is separated by subtraction. So my answer so far would be b squared plus 4 times b squared minus 4. But take a look at what happens. I have difference of squares again. You see this one here? Difference of squares again. So I have to do the pattern again. Kind of like almost having a greatest common factor. B squared plus 4 is going to come along for the ride, because I have to show that that is still part of the original equation. And now I split this one up. Two parentheses. The square root of b squared is b. The square root of 4 is 2. One is separated by addition, one by subtraction. So my final answer, okay, after doing difference of squares again, is b squared plus 4 times b plus 2 times b minus 2. Now I'd like you to do this practice problem on the left side of your book. You're factoring 9m squared minus 64.